Hello everybody, here is the 555 timer, and we're going to assemble it as per the schematic for the Protoboard exercise. Zooming in a little bit here, we can see the timer chip, and also on the left of it, please notice that there is a notch, and so the pin right below it is pin 1, and then it goes all the way around counterclockwise, and you're going to end up on this top left being number 8, pin number 8. Alright, so the first thing is we need to work our way through the schematic in the assembly, of course. And one of the first things that we talked about is about supplying power to pin 8. Granted, we're going to connect this jumper to the power rail up here. And the power rail is going to be basically this entire top row of holes, and that's going to be the positive power rail. And we're going to let the blue, which is down here, this set of holes where the blue line is, that's going to be our ground rail. So right now I've connected pin 8 to the positive rail on the Protoboard. Next, I'm going to take care of pin 1 and connect it to our ground. So I'm going to attach this pin here and connect it to our ground rail, which will be down here. And pretty much any of the holes on the ground rail will be fine because they all make the same electrical point. Next thing is we can connect pin 4 to pin 8. I'm going to use a yellow wire, so I'm going to connect pin 4 to pin 8, and thus applying power to pin 4 through the wire that's connected to pin 8 right here. You can see that the power will be supplied to all the pins, or the holes I should say, connected to pin 8, and therefore we can tap into the positive rail by using this jumper, which is connecting pin 4 to pin 8. Next, we can connect pin 6 to pin 2. For that I'll use a green wire. So I'm going to connect pin 6, which is around here. And I'm going to connect that to pin 2, which is right here. Alright. Now we also need to put some resistors. Now there's some resistors here that we're going to be using in parallel. So I have a 10k ohm resistance. You can see the value there. So I'm going to bend it as such, and I'm going to put two 10k ohm resistors in parallel to give me 5k. I'm going to grab another one, and I'm going to bend it the exact same way. And how I'm going to do this is I am going to connect them a little bit off of the chip itself, just to allow me to be able to better make use of the space. And so now that I've done this, and again, as you can see here, I am connecting these two together, and so they are in parallel. Now please notice that the resistors do not have polarity. Alright, so I can attach them any which way, really honestly, okay, to either end. But you can see that these two ends are connected to each other, and the other two ends of the resistors are connected to each other. Therefore, these two are in parallel, and if I was to measure with an ohm meter across them, I would see 5k ohms. Now to connect them into the circuit of the IC chip of the 5.5 timer, I'm going to connect this lead over to pin 7, which is right here. Right there. And I'm going to connect the other end of the parallel resistors to pin 8 or 4, but both pins 8 and 4 are connected to plus 9 volts, so I'm going to connect that to my positive rail right there. Alright, so I've connected it up there. Let's turn it around a little bit so you can take a better look right there. Now with that done, I'm going to connect a resistor, another 10K, and this resistor is going to be between my pin 7 and pin 6. Again, pin 7 and pin 6. So in order to be able to, now the thing is, pin 7 and pin 6 are right next to each other, and it's kind of hard to squeeze the actual leads like really close to each other, something like this. So I'm going to go ahead and just connect one end of the resistor, primarily the one that I'm holding on to right now. I'm going to connect that to pin 7, and I'm going to leave the other end just using one of the holes somewhere else that's not connected to anything. I'm going to put that right there. Let me turn it around so you can get a better look. Right there. Okay, but it is connected to pin 7, and then the other end is just hanging out there. Well, actually it's not hanging out because I've inserted into a hole right there. But that end of the pin will be connected to pin 6. So I'm going to use another wire, and I'm going to connect this end that's all by itself, and through the use of the jumper, which is up here, connect it to pin 6. So let me turn it around a bit, and I'm going to connect it to pin 6, which is right here. Alright, there it is. Now with that, I also need to connect a capacitor down to ground from pin 2. So let me grab one of those. Here I have the 10 microfarad cap, and you can see that we have some dashed lines on one side. So the lead that's closest to these dashed lines, that's the negative side of the capacitor. Now one of the things that you'll notice as I lay it down here though is that one of the leads is longer, and that typically is the positive side. But the thing is, when you put it into a breadboard, it makes it kind of hard to work with because one lead is longer than the other. So what I'm going to do is I am going to clip a little bit of the lead off, and using some wire cutters, but mine are a little bit magnetic, so it's kind of giving me a little bit of a problem here. You can use a pair of scissors if you'd like. These are fairly thin leads, so therefore you can do that. And you can see that I've cut them to about the same size right there. Now what I'm going to do is, for the schematic, the negative lead goes to ground and the positive of the cap goes to pin 2. So I'm going to straddle this right across here and connect it right there. Let's take a closer look right there. Okay, now make sure that it's gone into the hole. Let's try that again. Make sure that it's inserted properly. There we go. Alright, now the other thing we need to do is we need to get a 560 ohm resistor, and again I'm going to bend it a bit, as you see right here, and I am going to connect one end to the positive rail, and what I'm going to do is just hang this one out just a little bit out here, maybe about here. That'd be good. And again the positive rail, so let's attach that right there, and you can see how it's attached, how it's connected. Then I'm going to get the LED, which I have right here. Please note that one lead is longer than the other. The longer one is the anode, and inside you can tell which is the real thin part and the real big wide fat part. The thin part, the one on the right, is going to be the anode, and you can see that it is the longest lead as well. So I'm going to connect the anode to the resistor, and the other end I'm just going to jump that center channel, make sure it's inserted all the way, and then I'm going to connect another lead that goes from the cathode of the LED and I'm going to connect that one, or the other end of that lead, to pin 3, which is right here. Okay. Now the only other things that we need to do is to supply power. I have a red lead that I will connect to the positive rail. So I'll plug that up right at the very end of the positive rail. I'm going to get the black lead here and connect that to the negative rail, or the ground rail, and I'll connect it right here. And now at these two ends right here, I'm going to connect alligator clips through which I'm going to connect a 9-volt battery. So I'm going to get alligator clip right here, connect it to the negative, or the ground side. You can see the other end of the wire. And then I'm going to connect a red alligator clip to the positive side, to the positive rail, connect it there. And now I have these two leads up here through which I can connect a 9-volt battery. So let's take a look at the circuit. Here's the battery here. And when I connect it, hopefully that LED should start to blink. Let me connect the negative to the negative side of the battery, or the ground to the negative side of the battery. Put that there. And now let's connect the red lead to the positive side. And there we are. And as you can see, the circuit is blinking, and that of course tells me that everything is wired as it should. Thank you.